Good evening, geometry students. I am bringing you this review of the review. Basically, what we're going to do is we're going to walk through these problems because this is the first one. I am going to go through all of them. Normally on a test or a final or a midterm, I just go through like odds or evens, but on this one, I'm doing all of it. So, let's get going. So, first, name 2 points collinear to point K. So, when we're talking about collinear, that means on the same line. So, we're looking at A right there. Now, we can either go up and down to M and N. I think I went left and right and did... Well, apparently I just sat there and scribbled on it. Anyway. That right there. J and L. But M and N is also a fine answer too. So another name for line B. So line B is right here. And we can also name a line using 2 points. So if we know 2 points on the line, we can name the line that way. So we name H and K, and then remember we put a line over it with arrows going both ways. If we just put one arrow, it's a ray. If we put no arrows, it's the line segment. So it's important that we have both of our arrows. The intersection of line C and plane R. Line C is that one that goes up and down. Plane R is the plane given. So they meet. If we were to backtrack along the line until we intersected plane R, we'd get point K. And then a non-coplanar point to plane R is either going to be M or N. I picked M, but N would be fine as well. There are 5 planes on that figure. So what is important to understand is what a plane is. A plane is remember we can identify a plane by any 3 non-collinear points. That means 3 points not on the same line. So when we're looking at this pyramid on top of a plane, each side of the pyramid represents its own plane. So we've got plane ADE, DCE, CBE, ABE, and then we have that bottom square, which is also plane W. So that's where we get 5. So another name for plane W, and there are a bunch of different options. So we have, remember what I just said was that a plane can also be described by 3 non-collinear points. So if we have these points here, we have 4 points on there, so we just need to randomly pick 3 of them. So we can pick ADB, we can pick DCB, we can pick ABC right there, we can pick ACD right there, and I think that's it. There are 8 total that you can choose. So, name the intersection of plane ADE and plane W. So ADE is this one right here. It's that left-handed side one. W is that base one. Now, what is important to remember here is that when 2 planes intersect, they intersect at a line. When 2 lines intersect, they intersect at a point. When 2 planes intersect, they intersect at a line. So the line here is going to be line AD. And name a point non-collinear to points A and B. So A and B runs right here. Just pick any point. I picked E. Okay, so moving on. So, topic 2, segment addition postulate. So remember, the segment addition postulate is what we get is if we take I always use my meter stick that I have in class as an example. If we take my meter stick and break it up into 2 or 3 or 4 or 10 different pieces, regardless of how long each one of those pieces is, if I added up all of their measurements, they'd add up back to a meter. So it's a segment addition postulate. The way it's actually worded is, like using this one as an example, that because E is between D and F, the distance from D to E plus the distance from E to F is going to be equal to the distance from D to F. And once I can state that, once I can sit there and go, okay, this is what that statement is, I can then just plug in everything. So DE becomes 7x plus 1. EF becomes 4x minus 3. And DF, it becomes, apparently me yawning, 42. So I'm going to add these up, 7. So first I'm going to rewrite these to put everything in the right position. 7x plus 4x is 11x. 1 minus 3 is negative 2. So we're going to add 2 to both sides. And we get 11x equals 44. Divide both sides by 11. And we get x equals 4. Now it's important to understand that this isn't actually our answer. What we were asked to find is the distance from D to E. We know the distance from D to E is 7x plus 1. We know that x equals 4. And so we can rewrite the distance from D to E with that 4 instead of the x. So it becomes 7 times 4 plus 1. That's 28 plus 1. DE equals 29. So, moving on. In number 10, it says in the diagram below, if JL equals 10x minus 2, notice JL is the entire length. JK is 5x minus 8, and KL is 7x minus 12. So the first thing I want to do is I want to set up my my statement. So I know that K is between J and L. So the distance from J to K plus the distance from K to L is going to be equal to the distance from J to L. So it's the two pieces added to each other become the whole. So JK is 5x minus 8. KL is 7x minus 12. And JL is 10x minus 2. So I'm going to rewrite that, putting everything together. (5x plus 7x is 12x. Negative 8 minus 12 is negative 20. And then we just have 10x minus 2. So I'm going to subtract 10x from both sides. We get 2x minus 20 equals negative 2. Add 20 to both sides. And I get 2x equals 18. Divide both sides by 2. And I get x equals 9. Now it asks for KL here. So we were told that KL is equal to 7x minus 12. We know that x equals 9. So we can plug that 9 back in. We get 7 times 9 minus 12. Or 63 minus 12. Which is going to give us 51. So KL equals 51. Now, S is the midpoint of RT. So what I like to do is, if they don't give me I don't know what my cats are all about tonight, sorry about that. If they don't give me a diagram, I just write my own. So here, S is the midpoint of RT. So we have R and T on the ends, S in the middle, which means that the distance from R to S is equal to the distance from S to T. So I know that from R to S is 5x plus 17. I know that from S to C is 8x minus 31. I know that those lengths are equal, so I can set them up like this. And then subtract 5x from both sides. And I get 17 equals 3x minus 31. Add 31 to both sides. You get 48 equals 3x. Divide both sides by 3. And I get x equals 16. Now RS was given as 5x plus 17. Plug the 16 in there. 5 times 16 is 80. 80 plus 17 equals, it's 97. I'll go back. I don't know why I wrote 107. That's wrong. It's 97. So if I wanted to double check this, I could also go and plug my x value into ST, which is 8x minus 31. And I get 97 there, and so that gives me proof that I did this right, because I know it's the midpoint, so the distances are equal. So there we go. So here, before we get going on this, something important. So it says if the line bisects segment AC, which simply means that it cuts that in half. We're talking about distances here. A lot of people look at this, and when they see bisect, immediately think about angle measures. So they're thinking that the angle of AB to the left is the same as AB to the right. And so they set these either up going this plus this equals 180, or these two are something like that. So be clear in your mind when you are either, because you're going to have on this test questions both related to angle measurement as well as like linear measurement. So just make sure that you're clear on which is which. I go put my bread in the oven. I'll be right back. And we're back. Minutes have passed in my time, seconds for you. It's like time travel. It's so cool. Anyway, so number 12. Important to know whether you're dealing with angular measurement, that is degrees, terms like complementary, supplementary, stuff like that, or linear measurement. We're talking about distance. So here's the important thing, and here's why it's confusing, is the word bisect. It just means to cut in half. So if you bisect an angle, you cut the angle in half. If you bisect a segment, you cut the segment in half. It is the same word, and we use it in both of them. So in this time, we're talking about distance, though. So we know that from A to B is 4 minus 5x. Let's get rid of this stuff up here so it's not confusing. And we know that from B to C is 2x plus 25. Now what we're trying to find here is the length of the whole thing. So it's, what we do is we realize that we have a bisector. So that means the two parts are equal. So we have 4 minus 5x equals 2x plus 25. We're going to add 5x. Whoa. Got ahead of myself there. We're going to add 5x to both sides. That's going to give us 4 equals 7x plus 25. Subtract 25 from both sides. Negative 21 equals 7x. Divide by 7. We get x equals negative 3, which is fine. Now, normally, you want to go back, check your work. We are talking about distance here. And so it's important to understand that distance can't be 0, or it can't be negative, but x can be. So our x is negative 3. So what we're going to go back is we're going to find out the total distance. Now here's the thing, it's AC, not AB. When I do this, so notice from A to B I got 19. So that means that B to C should also be 19, making A to C 38. 2 times negative 3 is negative 6, plus 25. Negative 6 plus 25 is 19. So it does, in fact, equal 38. So AC equals 38. Moving on, 13 is pretty tough. So here's the thing. B is the midpoint of AC. AC is the distance from AC to CD. The distance from A to C is the same as the distance from C to D. And then it starts giving us things like A to B is 3x plus 4. A to C is 11x minus 17. C to E is 49. And we have to find D to E, which is right there. So what we're going to do is we know that C to E is 49 right there. So if we can figure out the length of C to D, we can subtract it from 49, and that'll give us the length of C to E. Well, how are we going to find the length of C to D? Well, we know that the length of CD is the same as the length of A to C. Do we know anything more about A to C? Yeah, we know B is its midpoint, which means that the distance from A to B is the same as the distance from B to C. And that, more importantly, if that whole thing, A to C, is 11x minus 17, and half of it is 3x plus 4, we can double that 3x plus 4, and it'll be the same as 11x minus 17. Distribute that 2, so we get 6x plus 8 equals 11x minus 17. Subtract 6 from both sides. We get 8 equals 5x minus 17. Add 17 to both sides. We get 25 equals 5x. Divide by 5, and we get x equals 5. So what I did next is I know that the distance from C to D is 11x minus 17. So I can plug a 5 in there. $55 minus 17 is 38. 49 minus 38 is 11. So D to E is 11. So there's some confusion on this next page. So where it says distance formula and midpoint formula, that's just a place for you to write the formulas down because you're going to be using them. There's been some confusion with the idea that the distance formula or midpoint formula meant that everything on the left-hand side would be distance formula, and everything on the right-hand side would be the midpoint formula. That's not it. These are just kind of references. That being said, it is important. I would write it down. So 14. You have, so when you're identifying your points, x sub 1, y sub 1, x sub 2, y sub 2, those are just ways to keep track of which point you're calling point 1 and which point you're calling point 2. They're just identifiers. It really doesn't matter. So if we go find the distance from S to T, well, that's going to give us our x2, because we know it's x2 minus x1 squared. Whoa. Plus y2 minus y1 squared. So we start plugging things in. x2, negative 2, minus x1, negative 3 squared, plus y2, 3, minus y1, 10 squared. So that's going to give us, those two negatives there are going to give us negative 2 plus 3 squared plus negative 7 squared. Negative 2 plus 3 is 1. 7 squared is 49. 1 squared is 1. 1 and 49 is 50. So we get our answer as the square root of 50. Plug that into a calculator. We get 7.07. Basically repeat this exact same thing for number 15. Label our points x1, y1, x2, y2. Plug it into the distance formula, which is up at the top left-hand side of the screen. x2 is negative 4. x1 is 8 squared. y2 is negative 2. Minus y1, which is negative 7. So negative 4 minus 8 is negative 12. That turns into negative 2 plus 7. Negative 12 squared is 144. 7 minus 2 is 5 squared. So that gives us 144 plus 25, which is 169. Square root of 169 is 13. So on 16 and 17, what we're going to do is the exact same thing as on 14 and 15, except we need to identify the points first. So for W, it's negative 2, negative 2. And for V, there's no movement on the x-axis, so we just put it at 0 and 4. I'm not sure what just happened here. I went all the way back. Hold on. Okay. So we label our points x1, y1, x sub 2, y sub 2. Plug it into the distance formula. Get the square root of 40, which we simplify, or we apply the radical. It's 6.32. So for 17, we figure out that it's negative 5, negative 1, and 2, 4. We put our x1, y1, x2, y2 on them. Does not matter which way you do that. It all washes out. We have our x1, y1, our x2, y2. We go ahead and plug it in. So instead of x2, we write our 2. Instead of x1, we write negative 5. That Instead of y2, we write negative 4. Instead of y1, we write negative 1. Math it out. That turns into 2 plus 5. That turns into 4 plus 1. 2 plus 5 is 7. Negative 4 plus 1 is negative 3. 7 squared is 49. Negative 3 squared is positive 9. And 49 plus 9 is 58. Drop that into a calculator, and we get PQ equals 7.6. Okay? So if on any of these you're having difficulty, go back, and you're trying to do this at home, go back, look at it a couple times, stop the video, rewind it, look at what you're doing, look at how it's different than what I'm doing. If that doesn't work, ask me a question. Come in at lunch. Come in, during class. We'll have all class on Monday to work through this. So these next two are midpoint and endpoint. Number 18 is midpoint, so we should have already written the midpoint formula up at the top of our test. Here we have 2 points. We have H, which we're going to call x1, y1. We have K, which is going to be x2, y2. And we want to know what the middle point in between them is. Well, we know that so x sub m, y sub m. That m just indicates that we're looking for the midpoint. That's why I chose m. You could do it as x3, y3 if you really wanted to. So we're looking for the midpoint between point 1 and point 2. So looking at our formula, we know that the x midpoint is equal to the average of the two x's. X1 plus, for some reason, it's being silly. Oh, there we go. Touchscreen's not acting fantastic right now. So it's x1 plus x2 over 2. The y midpoint is kind of the same thing, y1 plus y2 over 2. And then I just plug in the points that were given to me. So I know that x1 is negative 1. And x2 is negative 7. So I add those two up. Divide by 2. Negative 7 minus and negative or plus a negative 1 is a negative 8. Negative 8 divided by 2 is negative 4. So now we repeat that process. So that's our x coordinate. It's negative 4. Now we're going to repeat that whole process with our y coordinate. So we have y1 plus y2 over 2. So that gives us 2 plus a negative 4. So we have 2 minus 4, which is going to give us negative 2 over 2, or negative 1, which means that the midpoint here was negative 4, negative 1. So notice then for 19, sorry. So find the coordinates of z if y is the midpoint of xc. So here we're given 2 points. We're given x is negative 10, 9, and y is negative 4, 8. Now we're not actually looking for a midpoint between those two. We know that y is the midpoint, so we're looking for the other endpoint. So my computer just reset, so this is going to actually rewind a little bit. But so we have z as our point, we have x is one endpoint. We're given the midpoint, and we need to find the other endpoint. So this is done on a graph, so it's 2-dimensional. But think about it in 1-dimensional. If I started at 0, And when I got to 10, I was halfway there, and go, oh, then the whole thing is 20. And that's kind of what we're doing here. So we know we're starting at x, which is negative 10, 9. We know that negative 4, 8 is halfway there. So we're trying to figure out where the other endpoint is. And the formulas we use for those look like this. X sub 2, that's the x value of our endpoint, is equal to 2 times x sub m minus x sub 1. So we double the midpoint value and then subtract the endpoint value. Same thing for y. 2 times y sub m minus y sub 1. So x sub m is negative 4 minus x sub 1, negative 10. That gives me negative 8 plus 10, or 2. Y sub 2 is going to equal 2 times y sub 1, which is 2 times 8, minus y sub 1 is 9, so we have 2 times 8, 16, minus 9, 7. We then have point z is 2, 7. And if you look at how x changes, that should make sense. X went from negative 10 to negative 4. That's a change of plus 6. And that's halfway. So another plus 6, we end up at 2. Y went from 9 to 8. That was minus 1. That was halfway. So another one would be negative 1 or 7. We end up with 2, 7. So it's exactly what that makes sense. Okay, on to topic 4, angle measures. So this is where we talked about yellow and blue make green. We know that the two inside angles add up to the measure of the big outside angle. Sipping my coffee so I don't fall asleep. So we know the measure of angle DEG plus the measure of angle GEF equals the measure of angle DEF. So notice how I color-coded them, so you see which angle is DEG, which angle is GEF, and which angle is DEF. So then I just plug it in. 12x plus 1 plus 15x minus 3 equals 117. So I'm going to rewrite this, putting, and I put 15x, it's actually only 5x. So let me go to where I fixed that. There we go. So it turns into 17x minus 2 equals 117. Add 2 to both sides. Divide by 7. I'm just going to rewrite that. Okay. So we're erasing all this. And so we know that DEG is 12x plus 1 plus, that's GEF, is 5x minus 3, and those have to add up to 117 degrees. Because what we're basically doing is taking this big outside angle right here, and we know that that's 117. So whatever all the inside angles are, they have to add up to 117. So 12x plus 5x is 17x. 1 minus 3 is negative 2. I'm going to add 2 to both sides. 17x equals 119. Divide both sides by 17. And we get x equals 7. And that's all we have to find. So next, on this one, same deal. We have a yellow angle, a blue angle, and the big outside one is a green angle. In this case, PQS is 16. So we have the measure of PQS plus the measure of angle SQR equals the measure of angle PQR. So that tiny yellow one, the larger blue one, and then the one that encompasses both of them, which is green. So here PQS is 16, SQR is 9x plus 17, and PQR is 12x minus 6. So I combine like terms. 9x plus 16 is, or apparently I'm rewriting it to put everything together, and that's going to be 32. Sorry, not 32, it's 33. Subtract 9x from both sides. That's 12x minus 6. So that gives me 33 equals 3x minus 6. I'm going to add 6 to both sides. 39 equals 3x. Divide both sides by 3, and I get x equals 13. Now notice it was asking me to find PQR. So the measure of angle PQR is 12x minus 6. So I plug in my 13 for my x, and I get 156 minus 6, or the measure of angle PQR equals 150 degrees. Okay, again, this one's a little tough. So, but it helps just to kind of like break down what it is as what they give you as they give it to you. WXZ is a right angle. That means it's 90 degrees. Now this next one, it says the measure of angle WXV is 11 more than 3 times the measure of angle WXY. So what we do in this is we take the one that is being related back to, in this case WXY, and we say that's X. So if that's X, then WXY is 11 more than 3 times that. And then we're told that that angle right there is 139 degrees. So we know that if we add X plus 3X plus 11, we're going to get 139. So ultimately what we're trying to do here is we're trying to find the value of YXZ. That's the bottom part of that right angle. So if we can figure out what X equals, then we can just subtract that from 90. So 4X plus 11 equals 139. Subtract 11 from both sides, we have 4X equals 128. Divide both sides by 4. You get X equals 32. So that's 32 degrees right there, which means that's what is left over is going to be 90 minus 32, or we get the measure of YXZ as 58 degrees. Boom. Moving on. So again, here we have KM bisects JKL. Now, unlike we were talking before, here we're talking about angular measurement. So we know bisects means it cuts into 2 separate and equal angles. We also know that JKL, the big outside angle, is 92. So if we know that MKL is 5x plus 1, and we know that KM bisects JKL, it means that JKM is also 5x plus 1. So when we're solving this, we know that 5x plus 1 is half of 92. So if we double 5x plus 1, that should be equal to 92. So we get 10x plus 2 equals 90. 2. Subtract 2 from both sides, and we get 10x equals 90. Divide both sides by 10, and we get x equals 9. And that is all we're asked to do, is find the value of x. So now we can move on. Here, we're told that EF bisects AED, so we know that those two are the same. We know that AEF is 4x plus 3. And we know that FED is 7x minus 33. So those are going to be equal to each other. And that's my cats just breaking my house, as they do. So we have 4x plus 3 and 7x minus 33 are going to be equal to each other. Now, we also know that what we're looking for is CEB, which is going to be a vertical angle to AED. So what we're going to be able to do is we're going to be able to find X, plug X back into those angles, figure out what that total angle is, or just figure out what one of them is, double it, and that's going to be equal to CEB. So let's start off by figuring out what X is. So we know that 4x plus 3 and 7x minus 33 are going to be equal to each other. Subtract 4x from both sides. We get 3 equals 3x minus 33. Add 33 to both sides, and we get 36 equals 3x. Say that 10 times fast. Divide both sides by 3, and we get 12 equals x. So now we're going to take that 12, we're going to plug it back in. I'm going to use AEF, which is 4x plus 3. 4 times 12 is 48. So we have 48 plus 3. 48 plus 3 is 51. So if AEF is 51, FED is 51. I could also plug the 12 in there. 7 times 12 is 94. 94 minus 33 is 51. Or 84, sorry, not 94. So 51 plus 51 is 102. And because we have vertical angles there, we know that CEB is 102 degrees. Okay, we're almost done. Which diagrams show adjacent angles? So adjacent angles are angles that are next to each other. They have a common side and a common vertex, but no overlapping points. And all of these show adjacent angles except for A and E. Notice A and E each have 2 angles that do not share anything. They don't share a vertex. They don't share a common side. But all the rest of them do. So B, C, D, and F. So some of you guys might be looking at B and going, hold on a second, 1 and 2 aren't adjacent angle, which is true, but the diagram does show adjacent angles, even if it doesn't label them as 1 and 2. And that's kind of how I was looking at this. If you had not included B in your explanation as well, I was looking at 1 and 2. 1 and 2 weren't adjacent. That's a reasonable position to take. Vertical angles, again, the only ones that are labeled as vertical angles is B, but which diagram shows vertical angles? Well, B does, D does, and F does. Which diagrams show complementary angles? And remember, complementary angles mean that they add up to 90 degrees. So which diagrams show complementary angles? Well, A does, because 61 plus 29 is 90. Now, for 2 angles to be complementary, they don't need to be next to each other. It is simply that their measurements add up to 90 degrees. So A works. B, that angle 2 and the one right to the right of it would be complementary. C doesn't look like it. And then D and F, kind of for the same thing, that B, D, and F are all the same diagram. So even though, let's say, look at F, clearly 1 and 2 would be complementary, even though on B, they're not labeled, I took this as they're still showing complementary angles. Supplementary angles, again, the same thing. B, D, and F do show complementary angles. It would be, or supplementary angles, as exhibited in D. E does as well, because supplementary means they add up to 180, and 45 plus 135 is indeed 180 degrees. So B, D, E, and F. Now, a linear pair need to be both complementary or supplementary and adjacent. So we're looking at which ones show up under adjacent, B, C, D, F, and supplementary, B, D, E, F. And so notice both C and E are out. C's out because it's not supplementary. E's out because it's not adjacent. So we're left with B, D, and F. And that's it. So for these two last ones, you have to figure out what their relationship is, and then use that to create an equation for which you can solve for x. So notice both on 30 and 31, you're solving for x. So the first one, those are vertical angles. They're my bow tie angles. So we set them equal to each other because vertical angles are congruent. We're going to subtract 10x from both sides. And we get 1 equals 2x minus 5. Add 5 to both sides. 6 equals 2x divided by 2. And x equals 3. You can double check that by plugging the 3 back in, and you'll get that each of those angles is equal to 31 degrees. And then finally 31, solve for x. Here they are not congruent, but they do have a special relationship. They're a linear pair, which means they're going to add up to 180 degrees. So now we have 4x plus 7 plus 2x plus 5 equals 180 degrees. 4x plus 2x is 6x. 7 plus 5 is 12. So when I subtract 12 from both sides, I get 6x equals 168. Divide both sides by 6. And I get x equals 28. Hopefully this helped. If you have any questions on how to do anything, make sure, or what's going to be on the test or anything like that, let me know. And I will see you guys, well, it's already 12:30, so later today. Bye.